Hey everyone, this is Morgan. So we're going to be talking about what I call a mathematical treatment of acids and bases today. And everything is really going to be based upon this reaction. 2H2O liquid auto-ionizing into H3O plus aqueous and OH minus aqueous. And we wrote the KEQ for this a few pages back. This is what we have called KW. Okay? Now, I've always liked this graphic. First shown to me by my high school chemistry teacher, Dave Kukla, over at North Hollywood High. Probably 1984. So this is a graph of pH. We'll put neutral in the middle there. Anything below 7 is acidic. Anything above 7 is basic. Now, when it's neutral, the H plus and the OH minus are equal to each other. But as we get to an acidic solution, the H plus increases in concentration and the OH minus decreases in concentration. However, if you're acidic, the OH minus concentration gets bigger than the H plus concentration. So for acids, what we're saying is the concentration of H plus is greater than the concentration of OH minus. And for bases, the concentration of the H plus is less than the concentration of the OH minus. And in terms of an actual number, for acids, the H plus concentration is greater than 1.00 times 10 to the negative 7. And we're dealing with this at 25 degrees Celsius. This is all at 25 degrees Celsius. And for bases, the concentration of the hydroxide is what is greater than 1.00 times 10 to the negative 7. Okay? Now, we're going to go over something like 17 orders of magnitude here for concentrations. So it's going to help if we know a little bit about logarithms. So the log base 10 of A is equal to B, such that 10 to the B will be equal to A. Okay? That's an important property. That's the definition of logs, basically. Now the log base 10 of AB is equal to the log of A plus the log of B. And the log of a quotient, A over B, is the log of A minus the log of B. And we have the special case where what if A is 1? The log of 1 over B equals negative log B. Okay? Now, pH is defined using base 10, or what we call, when I was in school, we called them common logarithms. Okay? So pH equals the negative log of the H plus concentration, which would mean that the hydrogen ion concentration is 10 to the negative pH. There is a corollary called pOH, which equals the negative log of the OH minus concentration, or that the OH minus concentration would be 10 to the negative pOH. Okay? So what we can say is that pH plus pOH will be equal to 14. Now this actually comes from KW, which is 1.00 times 10 to the negative 14, which equals the H plus times the OH minus. So I'm going to take the negative log of both sides. The negative log of 1.00 times 10 to the negative 14 equals the negative log of H plus. And remember, when you have a product, it's the sum of the logs. So plus the negative log of the OH minus. So when I run that through a calculator, I get 14, which equals pH plus POH. All right? Sorry about the sound effects there. There's a cat screaming at me. So something similar here. KW we showed was equal to KA times KB. So PKA plus PKB add up to be 14. All right? So we have said that typically the pH of pure water is 7. Now that's actually not true in most situations. Okay, so 2H2O liquid breaks down into H3O plus aqueous plus OH minus aqueous. Okay? So if we make an icebox out of that, ICE, ignore that, 0 and 0 plus X. Sorry about the sound effects. I don't know if you can hear it or not, but there's a cat there telling me I'm an idiot. Okay, so X squared must equal 1.00 times 10 to the negative 14. So X, which is equal to the H plus, equals 1.00 times 10 to the negative 7. So then the pH is equal to 7. Now this reaction is endothermic. So again, I'm talking at 25 degrees Celsius. This number will get lower as temperature increases because you'll have more product and the value of Kw will increase. So now what we're going to look at on the next page is a graphic organizer for helping us to keep track of what we're doing here. And I have called it a square roadmap. And you have your H plus, you have your OH minus, you have your pH, you have your POH. And what this basically tells us is that you can't convert directly from H plus to POH or from OH minus to pH. You have to do it in a two-step process. Okay? Now, Sig Figs with logarithms. It is possible. Okay? Let's imagine that we have the number 1.00 times 10 to the negative 4th. Now that has 3 Sig Figs, the way we've learned to do Sig Figs. When you take the negative log of that number, 1.00 times 10 to the negative 4th, your calculator is going to tell you 4. Now, the times 10 to the 4th is the magnitude of the number. And the 1.00 is the measurement. The technical term for it is it's called Mantissa. Now, those 3 digits are the Sig Figs. And the 4 is just the magnitude. Over here, the 4 is just the magnitude. So we will add 3 zeros at the end. So when you're looking at something like a pH or a POH, the significant digits are the ones that come after the decimal point. Okay? We'll practice that a bit, don't worry. So now, do our first problem. HCl breaks up into H plus Cl minus. Fully dissociated, strong acid. So if we have 0.10 molar HCl, it becomes 0.10 molar H plus. And the pH is simply the negative log of 0.10, which equals 1 point, and we'll go 0, 0, because this has 2 Sig Figs. Okay? So we need to learn how to do that on our calculator, and that's the point of this table. Okay? pH plus POH add up to be 14. So if the pH is 10, the POH must be 4. The H plus is 10 to the negative 10th, because the H plus equals 10 to the negative pH, and the OH minus equals 10 to the negative POH. So, this would be 10 to the negative 4. It's a base, by the way. So, pretty straightforward idea. Now let's throw in some Sig Figs. The H plus is 1.00 times 10 to the negative 5th. We need to take the negative log of that. So, got the calculator here. All right. Make sure it's showing on the screen just right so you can see all the buttons. There we go. Pretty close. All right. So down here at the very bottom of the screen, I'm going to put the minus sign, negative. Over here, I'm going to push logarithm. 1.00 second EE negative 5 and close the parentheses. Okay? Now, I'm not going to use this thing. I'm not going to put in a 10. I'm using the EE button, which knows how to do scientific notation. When I hit enter, it tells me 5. And that's great. Okay? But it doesn't tell me the Sig Figs. This has 3 Sig Figs, so 5.000, which makes this one 9.000. And this must be 1.00 times 10 to the negative 9. Okay? That is an acid. The product of these is going to be KW. KW equals the H plus times the OH minus, which equals 1.00 times 10 to the negative 14th. Okay? So actually, if this is 1, this must be 1.00 times 10 to the negative 14th. The product there. Okay? So this actually makes the POH 0. And since that has 3 Sig Figs, I'll go 0.000, and this is 14.000, and this is quite basic. All right? Now, that's just great for powers of 10. What if we actually have something up front here? So, go back to my calculator. I'm going to turn over here, just look at the screen, make sure, yeah, you can see it. So, negative log 2.00 second EE negative 5. Oh, I'm sorry, negative 9. My boo-boo. Okay. Hit enter, and I get 8.6989, etc., etc., etc. 3 Sig Figs, so 8.699. All right, so this would be 5.301 and 10 to the negative 5.301. So let's check out how to do that here on the calculator. All right, 10 to the negative. So second log, or the anti-log, which is 10 to the x, negative 5.301, close the parentheses, and I get 5.00 times 10 to the negative 6. And that would be basic. Okay? So go through, try a few of these, then tune back in. All right, welcome back. Hopefully, you found that this was 6.35. And paying attention to 2 Sig Figs, this is 4.5 times 10 to the negative 7. And this is 2.2 times 10 to the negative 8. And it's an acid. If this is 1.23, this would be 12.77. 5.9 times 10 to the negative 2. And 1.7 times 10 to the negative 13. It's acidic. So if this is 10, this will actually be a negative pH, 1.00, negative 1.000. So this is 15.000, and this is 1.00 times 10 to the negative 15. And oh yeah, that would be acidic. Okay, that's pages 4 and 5. Thank you for tuning in. When we come back next time, it'll be weak acids. This is Morgan, signing off.